Hey everybody, this is my first time doing one of these YouTube videos this year, so I may be a little out of practice, so we will try and see how it works out. So I'm looking at 3 questions here in Notability, 66 through 68. Right, and the trick here really is the picture. Alright, so I'm looking at question 66 first. It says I've got 2 rugby players running towards each other. They are 37 meters apart. Okay, so I'm going to draw the picture here. Oops. There's one. There's 2. I'm going to give myself lots of room here. It says they're 37 meters apart. It says one's accelerating from rest at 0.5 meters per second squared. Okay, so what I know is, it says the other one's already moving at 3.1 meters per second, maintains her speed, and it says how long before they crunch together. So somewhere in here, they're going to collide, right? And wherever they collide, let's say I've got person A on the left here and player B on the right. Let's say A moves a distance of X meters. How far does B move? Well, B moves 37 minus X, right? Because if A moves 10 meters, B moves 27 meters. If A moves 17 meters, B moves 20 meters. If A moves 1 meter, B moves 36 meters. All right, so the distance for B will be the 37 meters less the distance that player A moves. Okay, so that's the important piece here. Okay, is that the X for player A and the X that's involved with player B's distance are related according to that relationship. Now, what I also know is that player A is accelerating from rest and has an acceleration of 0.5 meters per second squared. Player B has constant speed, right? Moving at 3.1 meters per second, maintains her speed, constant speed, right? So she's moving at 3.1 meters per second. I'm just going to switch my pen here. Okay, 3.1 meters per second. Now, I know that the distance traveled by player A on the left here can be determined based upon, so what I know is that when they go crunch, right, that means they're both in the same place at the same time. In other words, when they go crunch is when the time that A has been running is the same that the time that B has been running. So the delta T on this side is going to be equal to the delta T on this side because they both have the motion that will end at the same time when they collide, right? So they both will have the same starting time when they're 37 meters apart and the same ending time when they hit each other. So the time for both is going to be constant. So for player A on the left, if I say, what is the distance traveled by player A? Well, player A is accelerating, and I know V1, and I've got delta T up there, and acceleration. So if I look at how I'm going to analyze the motion for player 1, it's going to be V1 delta T plus 1/2 of A times delta T squared. Okay, so there is my motion for player A. I know that V1 was 0, so this whole thing becomes 0 here. I know delta D is X, and I know the acceleration was 0.5 delta T squared. I'm stuck here now. I have 2 equations. I have an equation with 2 unknowns. X is unknown, delta t is unknown. Let's go over to this side. What do I know about player B? Constant speed, so I can use my equation. Delta d equals v times delta t. Right? So there's my equation for constant speed. I know my distance traveled by B is 37 minus x. I know the speed of B is 3.1 meters per second. Put this bigger, see if it works any better. There we go, 3.1 meters per second times delta t. Okay, so I have 3.7 minus x equals 3.1 delta t. Now, but I know what x is, right? I've got x on this side over here. The x on this side is equal to a half of a half, which is a quarter, times delta t squared. So I can take that and substitute it into here. Substitute this in for x up here, and I now have an equation that has only one unknown, which is delta t. Granted, I have to do my quadratic, but I can solve for the time that it takes for them to collide. Once I know the time it takes for them to collide, I can answer all the other questions. So the question is, A, how long before they collide? B, how long will player A be going, the accelerating player, when they collide? And C, how far has each player run? In other words, what is x? Once I know what x is, I can solve for the distance for A, and I can solve for the distance for B. Right? And again, once I know what delta t is, the time before they collide, because I just calculated it, I can substitute it in right here, right into this equation here. I know delta t, and I know 3.1, and I know 3.7, so I can solve for my unknown, 37, and I can solve for x. Let me fix this up here. This should be 37. Minus x. All right, so there's your math for question 66. Let me just